everyone, welcome to the 376th episode of the Internet of Things podcast. This is your host, Stacey Higginbotham, and your co-host,
Kevin Toffel.
And we have a lot to talk about today. My goodness. First up, I'm no longer in a hotel room in some place that is not my house. Yay!
Yay!
All right, so we're going to talk this week about, congressional interest in Ring's quote-unquote surveillance program once again. We've got an update on Influx data, which is worth mentioning. Kevin has learned a lot tackling smart home projects, including when and why you should DIY. Siemens has made an acquisition in the industrial space. There is a really cool project showing real-time collaboration between two continents in the industrial IoT, and lots of little bits of news from GE Lighting, update on smart locks. We've got some more lighting news, and TP-Link's got some HomeKit support. Our guest this week is actually Evan Kaplan, the CEO of Influx Data. So you'll stay tuned for him. He's going to be talking about time series data and what the ideal stack is in architecture for industrial IoT. We're also going to hear from our sponsor, Nordic Semiconductor. But first, let's hear from another of our sponsors. This week's sponsor is Wirepass. Wirepass is on a mission to set a new standard in IoT. They believe in infinitely scalable connectivity software that never fails. Why not? And they concentrate on large industrial applications. Wirepass thinks it should be affordable. That's their mission. Wirepass is the future of enterprise IoT. With a recent 5G standard update, they've got a chance to change the IoT in a non-cellular way. You can learn more at wirepass.com. That's WIREPAS.com. Okay, let's start this episode off strong with a letter from Ed Markey. This is a senator, Democratic senator. He's very tech savvy, actually. And he sent a letter June 14th to Andrew Jassy, the CEO of Amazon, asking about Ring's quote-unquote surveillance program. All right. Everyone who's listened to this show knows that we have talked about the issues with Ring and then the steps that Ring has taken to kind of mitigate some of these issues. Basically, at its core, the Ring video doorbell, it tracks what's happening outside your home.
Like every other video doorbell.
Yes, like any other video doorbell, via video and audio. What's interesting, Ring got in trouble a couple years ago because they established these relationships with police departments around the United States. And the police actually became an extension of the Ring's marketing arm. They would encourage people in their jurisdictions to buy Ring doorbells. They would actually get Ring doorbells to distribute for free. There was a lot that people were like, Now, Ring's whole MO, if you talk to Jamie Siminoff, who was the founder, was basically to create this ring of security around your home. The idea being that if you see what happens in a neighborhood, you can help prevent break-ins and that sort of thing, which is all to the good, except for humans are messy, biased, horrible individuals sometimes. So what happened is you had a lot of people who were like racist. They were like, oh, no, a Black person is walking by my neighborhood. Call the police. When in fact, that person lives down the street and they just didn't know. So there were lots of worries about that. And then what happened is with the police involvement, what started happening is footage from Ring cameras could be subpoenaed and used in police departments, especially the LAPD. They did this not just with Ring, but with other video doorbells. They would try to get video images of protesters on certain streets. So they would actually subpoena doorbell camera information to try to see who was walking down the street at a time of a protest, for example, during the Black Lives Matter protests. So people started thinking, oh, yuck, I'm basically sticking an extension of the state surveillance on side of my house. And Ring actually did quite a bit. They stopped the program, the outreach programs with police. They made it so police had to have a case number in order to subpoena records, and homeowners could decide not to send it. They also made it so police couldn't actually access that data without the homeowner's permission. But Ed Markey, he's not satisfied. He wants to understand more. He really wants to understand a couple big factors, some of which I agree with. Like, to the best of Ring's knowledge, how far away can Ring products capture audio? Will Ring commit to eliminating Ring Doorbell's default setting of automatically recording audio when video is recorded? If no, why not? Could you commit to not incorporating voice recognition technology? So this is all about the audio capabilities. He wants Ring to make end-to-end encryption of stored video recordings the default. So Ring and Amazon don't have access to user videos. There's an issue with that because if you turn that on, if you lose your video, no one else can access it.
Mhm.
Now, some people may not care. That's kind of the point, but it is an important thing to note. He wants to know how many law enforcement agencies use Ring doorbell cameras or have relationships with people who are using it.
He noted that he last sent communication to Ring in 2019 with similar questions. And since then, the amount of law enforcement agencies that have worked with Ring on getting video and so on has gone up 500%. So he's concerned about that.
Yes. And this is true. Now, that doesn't mean law enforcement got that video. It basically means that law enforcement's like, hey, can we get access to this? There was a crime committed. Usually what happens is they'll say like, hey, there was a crime committed at this particular block and we'd like to see footage of your camera to see if we can catch the suspect. Most people would probably say, sure. That feels like an okay thing to do. But in the case of like, hey, we believe a crime was committed during this time. And if you don't realize, maybe that's a protest. Maybe that's something that you don't want to be part of. Maybe it's ICE, Immigration and Customs and Border Control.
Right. There's a lot that I understand and even agree with in the senator's questions, but a couple thoughts. As we said at the very beginning, much of this applies to any video doorbell. I understand why he's addressing Ring in this particular aspect, and that's because of their relationship with law enforcement, et cetera, in the past.
They're also the top seller of video doorbells.
Well, yeah, and that's fine. And it's funny, that comes to my second point, because I don't know that I agree with this statement, although this is obviously debatable. He says, since Ring has well over 10 million device users, it appears likely that Ring products record millions of Americans' activity without their knowledge every day. Maybe. I mean, I'd like to see some kind of study on that to make that statement, but okay. I see where he's going for. He wants to make sure that the public's right to assemble, move, and converse without being tracked is not at risk. That's basically what he's saying in that paragraph. And I would agree with that. Yeah, this is tricky. Ring kind of put themselves in a bit of a hole in the first place.
The relationship with the police departments, I get where it's coming from, but I also that was a mistake.
Right.
But I will say, like Google Nest, with their update to their doorbell camera that happened, was that earlier this year? They actually did a lot of things to really indicate to people that they were being recorded. So once a recording starts, they actually have a bright light that turns on. The doorbell ring lights up and starts spinning to indicate that they're being recorded. And I feel like there's a couple other things in there that were pretty, maybe not privacy part, but at least acknowledging that someone was being recorded. And this isn't going to help in the case of like police fishing for protesters' faces, but it would help like if you're a realtor, for example, standing outside someone's house as you leave, talking about like the house that you just saw. Like, oh my God, I can't believe their curtains.
In the bigger picture, this gets back to something I've been thinking about, and I know I've mentioned it once or twice in the past year or two, literally putting up a sign on my house somewhere that says, we use security cameras and microphones,
Those should come with your packages because that is something that you're supposed to do anyway, believe it or not.
And yet, in all my wandering around throughout COVID, because I've been doing a lot of walking and bike riding and whatever, I have never ever seen a sign like that.
Well, I put them up on my door. Like I used to have them on my front door. So you had to make it all the way up. And
there's a perfect example of why he's asking, hey, do these capture sound from 20 feet away? My front door is actually on the side of my house because I have an end unit townhouse. Yeah. And I've got cameras and microphones in the front of the house that people won't get to the front door, but I know I can hear them and see them because I do. I only save the recordings of interest that I've configured, obviously, and I don't go back and look at them unless I need to. But how do I disclose that to people?
Yeah, this is the issue of consent. I talk about this a lot in not just, I mean, anytime you bring a smart product home into your house, you are sharing information, and it's unclear to people sometimes what information. Like, for example, I just spent like 3 weeks living in a hotel, but every time my husband preheated the oven,
Yep.
I knew it was on because I got a little smart oven alert on my phone that said, "Hey, your oven's preheated."
I've gotten the same. And just for fun, I'd say, oh, let's see what they're cooking. And I have jokingly sent a text back saying, hey, how did the steak turn out or whatever? My family does not like that. They do not take kindly to those messages.
Yeah.
So I've stopped doing that. And that's inside a family environment.
Right.
Imagine if a stranger has that information, right?
So I get it. I think that we are entering into this weird
metaverse.
No. I was going to go with Panopticon.
Yes.
And I think it's important for people, like, there's no easy answer here.
No.
I get why people want to feel more secure, and doorbell cameras do. But I also feel like every time I'm on like TikTok or something and I see people who like show videos of their Amazon delivery driver doing something, I'm like, God, that feels gross. It's the same sort of grossness when somebody's puts up a cell phone video of someone misbehaving on an airplane. You're like, oh, that's kind of a jerk of them. But it's also like the person misbehaving, but it's also kind of like, ugh, what if someone is filming you without your consent?
Right.
It's just, ew. I don't know what we do with this.
I'm not a huge fan of regulation when it's not needed, but do we need some kind of standards that all these devices must adhere to in terms of disclosure and encryption and storage? And
I think, yes, we need that. But I also think we need to establish regulations about how and when that device can be collected and used.
Yes.
And we don't really have anything like that right now. Wiretapping laws are the extent of what we have, and the courts have really kind of gone all over the place in terms of like what's legal and what isn't.
Well, I mean, those laws were built designed when wiretaps was actually tapping wires as opposed to
like physically going into a telephone and
right.
screwing in a button.
We need to update a lot of, as the technology has changed, we need some generic updates to a lot of those older laws on the books to encompass the new technologies, quite honestly, because it's a gray area right now, you could argue.
It's totally gray. And right now it's being used, I would say, against people.
Yes.
Okay, so we'll see if anything comes of this. Senators have asked this in the past. You mentioned that people are still using this and using it more and more, so that's kind of creepy. All right, let's move to data analysis, specifically the analysis of time series data. So InfluxDB, or Influx Data, which makes the InfluxDB database. It's a time series database. It competes with Predix or Amazon's TimeStream. Azure has one too that I can't recall. And later on, we'll actually talk to the CEO of Influx Data. But this week, they announced something called Edge Data Replication. And basically what this does is now your time series data can be kept local and also replicated to the cloud, and they can synchronize and eventually become the same, which is important for people who want to do things like, hey, if you want to do AI training in the cloud, you need to get that up there. Mm-hmm. The cool part about this is they've allowed for lots of tools to let you do a couple things. One, it'll help establish rules for intermittent connectivity. So it'll tell you can choose, like, I want this data to go first. And if the internet goes out, because that's an issue in industrial settings, believe it or not. Your internet is not as reliable.
And in space as well.
Yeah, and in space. You can say, I want to prioritize this data stream, or I want to prioritize the last 30 seconds of data, whatever you want. You can set those rules up. You also can filter the data at the edge. They've got a tool they call Flux, and this lets you like reduce the size of your data sets if you want. You can downsample it, so just get the most important relevant bits.
Yeah, why mirror data that, big gobs of data when you only need, say, the most important 10% of it?
Yeah, so that'll get you to save on bandwidth. It also helps like reduce like the time it takes to get it up there. And so anytime the connection is live between the edge and the cloud, it'll just process and send as much as it can. And it lets you take pretty rapid action in the cloud if necessary. This is big because the big theme in IoT is, we need edge and cloud, and we need it to work together, and we need it to be as synchronous as possible. We see this with software applications. That's why containers are so exciting for everybody. And we're seeing it now with databases. Yay. Moving right along. Let's talk about Kevin's. Oh, I forced Kevin to talk about this because I really thought it was. We always tell people to DIY if you can, because I fully believe that one, it's cheaper. Two, it gives you a sense of accomplishment. And three, the more you know and can do, like just the better able you are to navigate this world. So Kevin wrote about some of his recent DIY efforts, and I thought they were basically, he got into this because we're doing so much stuff in the smart home. And now listen to what he's doing, man. Tell him about your Tesla or your HVAC.
Yeah, I mean, I'll admit it. Early on, like way back in 2010, when I first got my Insteon system, it was Insteon server, I wasn't into electrically wiring smart home devices. And to be honest, you didn't really do that back then. You connected them through your Wi-Fi network or however whatever protocol was being used at the time. And so much has changed. And it really hit me most recently when I put that Eve outdoor cam up that I reviewed a few weeks ago, because when you say outdoor cam, a lot of people think, oh, it's just a camera with a USB port for power and I stick it outside or do whatever, or it's got a battery. No, it's a fixture that you literally have to hardwire. And it's no more difficult than replacing a non-smart fixture with any other fixture. But a lot of people wouldn't do it, even though it's just the 3 wires. And over time, since 2010, I mean, I've learned more. I've forced myself to do more DIY installs, whether it's a recent, it could be thermostat that I had to do, or whatever it might be, switches, smart switches, for example. There are so many resources out there to learn how to do electrical work, for example, just basic electrical work now, and to do it safely, that I've learned a bunch, pretty much a lot in the past year, that it's actually worked out that I can fix other things around my house that I wouldn't have bothered. And this is a silly but simple example that, yes, we got a new Tesla and, it checked out fine for quality, but then 2 days after driving it, the back seat on the passenger seat fell off. It literally just fell off.
I'm like, take it back.
Well, a lot of people probably would call Tesla, complain, take it to their service center, et cetera. But that's a hassle for me. I've learned so much just being on the internet. Somebody else had to have this problem. It's got to be simple. And no, there's no electricity involved, but hear me out on this. Sure, there's a trick to it. I mean, you have to find out how to raise the headrest of a Tesla. And there's a video on how to do that. There's just 2 small little clips underneath the fabric. I move those clips, lifted up the headrest, and then put the seat back in because the headrest poles actually hold the seat back. So it was a 5-minute fix, and a lot of people I don't think would do that. But again, having experience doing smart home and even non-smart home projects around the house has helped me. I don't know if I mentioned on a previous show that our air conditioner died about a month ago during a massive heat wave. It was 99 degrees outside. It was 82 in the house. And nobody would come replace the system because it was a weekend or look at the system even. And again, I use my research skills and I'm like, I can open up the AC and just see if anything looks out of whack. And sure enough, the capacitor, which is used to give a jolt of energy to start the fan and the compressor, was bulging and it didn't look right. I ordered a new one for $15, got it the next day from Amazon, knew from my little electrical experience to shut the power breaker off for the AC unit and the whole HVAC system, wire in the new capacitor, turn it back on, and we had AC. It was fixed. And instead of spending hundreds and waiting for somebody to come do it, I was able to do it myself. Then one final example, and this is maybe more advanced than people want to get, but again, over time, you gain experience and you gain a comfort level. I am redoing the 3rd floor loft in our house, making it a bedroom. We built a closet. One problem, the current thermostat for the baseboard heater is now inside the closet. That's not going to work. So I went in the attic and I'm like, I can move these wires to the other wall. Let me just hit the breaker and turn off all the power, move these wires. And I did it. I moved the thermostat to right above the current light switch outside the closet. And it's done. Now, if you're not comfortable with these things, of course, you should hire a professional. I'm not saying everybody should just abandon the electricians and plumbers and so on in the world. Don't do that. You want to be smart. You want to be safe. But don't sell yourself short either. You can learn a lot and gain some skills that will really help you to fix things around your own house, whether it's a smart thing or not.
Yes. And I would say this is especially relevant because right now it's really hard to get contractors. And also, we spend a lot of time talking about, like, hey, all of your hardware is really software now. This level of physical comfort and the ability to look things up on YouTube and to test things out could help you after a device gets bricked. Who knows?
Yeah.
I just thought this was another good reminder. And hearing all that you've done, Kevin, I was like, man, you should write about that because, people should believe in themselves. Y'all can do it. Okay.
Just be safe. That's all I always say. Just be safe and take pictures of things before you uninstall them and replace them or reinstall them. That comes to be so valuable if something doesn't go right. You can always revert back.
That is true. All right. And you mentioned something that we should also talk about, which is Insteon. Last week, Insteon, we talked about, hey, the Insteon servers are back. Yay. But we didn't know who bought it. But now we do. Ken Fairbanks is the new CEO of Insteon. A group of Insteon users purchased the assets and plan to make it work. So your hubs are now online and they're going to get in touch with us eventually about how they're going to make this work.
Last week, we had said that the servers just magically came back online. People's Insteon hubs were connecting to the cloud. Things were working again, even though the Insteon apps were pulled from the various mobile app stores.
They're actually back now.
I was just going to say the apps are back. It wasn't easy for Fairbanks and the others to get communications out. So that's why it just kind of happened. And then the explanation came later. And we had said last week, back up your hubs if you can while it's working. I don't know that long-term I would pin my hopes on this staying up because we just didn't know. But now I feel comfortable saying, hey, they're going to give it a shot, so use it if you have it.
Smoke if you got them. All right.
Mm-hmm.
And now moving to some industrial stories. Siemens has acquired a company called Senseye. They did this earlier this month. This is an industrial analytics software company in the UK. They do predictive maintenance software. So they help improve predictive maintenance for machines. And now Siemens, which has a large industrial portfolio, will have this ability as well. So yay for them.
Yeah, what stood out to me, because I don't know if people understand the value of these predictive maintenance solutions using AI, ML, et cetera, whatever solutions they're using. Senseye has enabled reductions in unplanned machine downtimes by up to 50%, and maintenance staff productivity is up 30%. That's huge if you're a production line of some product.
Oh, yeah. And again,
huge.
Given supply chain issues, knowing that something is going to go down or is like teetering, you can order something well in advance or as far in advance or further in advance. You also, if you can stop a machine before something breaks, that's even better for you. And without having as much staff available, a lot of people in the industrial sector are older, they're retiring, it's hard to get new people. This is all to the good. So efficiencies, yay. Of course, they're making this a sustainability play, but we're not going to talk about that now. Other industrial news, this is super cool. And this is super cool because I'm a super nerd. Not everybody's going to, if you're only for the smart home, this is still super cool, actually.
It is. I agree.
Okay. So a research team, the Electronics and Telecommunications Research Institute, has basically created a lab in Finland that is actually, it's a replication and a control unit for a factory facility in Korea. And I can't say the name of where this factory is, but we'll link to the story in the show notes so you can try saying it. They've basically controlled this factory at over 6,000 miles difference. It's 100 kilometers difference. And the latency on this was 0.3 seconds. Now, that is a higher latency than you want for some mechanical things, but it's still freaking low. And the issue is they used 5G. They've connected the smart factory to this university. It's using a 5G test network. But this is awesome. Because you could imagine being able to, this gets us to the point where we could have people in central locations monitoring or even diagnosing issues in remote factories. You wouldn't have to fly everywhere. It does actually potentially cut down on the number of employees or experts that you might need, which is kind of sad from an employment perspective, but maybe good because we don't have as many people in this field as we used to. So yeah, this is, I don't know. I think it's just really awesome.
It is. It reminds me of some of the tests a few years ago where somebody in one continent would remotely control a robotic arm or a prosthetic on somebody, on another continent, right? The fact that you can do that with such low latency, say in a factory setting or a healthcare setting, maybe you can remotely operate on somebody, the doctor can't be on site and he or she is the best at this procedure. They could just hook up to the network and, smartly do the procedure. There's so many implications for this type of technology that it's mind-boggling to me.
It's awesome. All right, let's go for some quick news bits. First up, Parks Associates. They released a white paper earlier this week that noted that there are 12 million smart locks in U.S. households. Yay. The number one reason why people bought a smart lock was to minimize key replacement costs. People are losing their keys. People also want to track who enters and leaves. They want to give remote access to cleaning people or home viewings if you're a realtor or guests if you're an Airbnb. Basically, all of the reasons were pretty much the same level of importance.
Makes sense to me. I mean, we've gone away from keys completely in our house now. It's all phones and watches, which is really amazing. You don't have to worry about a key. I still have one problem with the report. How do they know it's not 6 million households with a front and back door with smart locks?
Okay, they don't. All right, other news. RTI is integrated with Oro Intelligent Lighting. I just threw this in here because RTI is a smart home integration company. But I really was excited about this story because Oro is very cool. This is a smart lighting switch maker. And what they do is their switches actually, they do predefined lighting routines for people, are able to do like presence detection. They're basically like the coolest, smartest switches ever. And I should probably try them out. Maybe I'll do that. Okay, other news. TP Links, they've got new smart plugs and they've added HomeKit to them. And energy monitoring.
Yay.
Yay.
Yay. I'm happy.
Yeah. So, I mean, I have a couple of these Casa smart plugs. They're lovely. You can buy a 4-pack for $50 that supports HomeKit.
Yeah. I mean, as excited as I am to see more HomeKit products, because I do use HomeKit these days, I'm actually thinking of not doing smart energy monitoring at the individual plug level. I think a whole home system that's truly smart would be the better investment for me personally.
I agree. I will say, as a person who tests IoT devices, sometimes it's kind of fun to see
True.
But yeah, I'm with you.
Yeah.
That concludes the news portion. But now let's listen to y'all. This is the Internet of Things podcast hotline, the segment of the show where we take your questions and comments and respond. You can reach us at 512-623-7424, and we encourage you to call us with your questions and comments because you will be entered to win. We're throwing out the Eve Aqua, which is a hose monitoring system, but I'll also get you an Orbit Beehive if you don't want the Eve.
Well, we're not throwing it out.
No,
it's a good product.
It is a good product. We've tested both. So you will be entered to win if you call us at 512-623-7424. And really, I want to hear from y'all, man. All right, this week's question comes from Tommy. Let's hear it.
Hello, fan of the show. My name is Tommy Haunton. Here's my question. My partner and I are looking to get a house soon, and I just began wondering, I have a ton of smart home stuff. I have Hue lights, I have bulbs, I have you name it. Would love to figure out some advice on when we move in and are looking for a place, what process should I take to try to get actual fixtures and try to integrate the whole home with Hue? I've read about switches and trying to install bucket lights, and I was just wondering, is there a way or a method to kind of wire a smart home and things to look for as we're sort of kicking the tires on different places? So I would love some advice kind of going at it blind. So thanks.
All right, Tommy. Well, we have lots of news and information for you. So much.
And opinions.
All right. Don't do bulbs. That's the first opinion.
There you go. What should they do?
Not
smart
bulbs.
Switches?
Now, if you want to, it sounds like you want to stick with Hue. Hue has a limitation in the fact that each hub only supports 50 bulbs or 50 devices rather, which is kind of limiting if you have a big house. I don't know if you've ever counted the number of bulbs or switches, but that's worth noting. You can have 2 hubs in your house, but they only work one at a time. So again, that's a limit.
It can be. I mean, everybody's house is different. Obviously, we don't know how many lights he wants or needs.
Yes, but it is a factor to consider. So
yes.
I vote switches. And I vote switches because, one, if you can only control 50 of them, you probably have fewer than 50 light switches, and that gives you room for, other things. So Hue doesn't have wired light switches. So you would have to switch over to something like Lutron, which is my recommendation to everyone, which is another hub. So if you want to stick with Hue, here's what you would need to do. You would have to do the Hue bulbs, which if you do the Hue bulbs, what will happen is they always need a connection. So your connection needs to be on all the time, which means your light switch becomes non-functional. Because if you turn the light switch off, your bulbs are going to not work.
Yeah,
So,
they need power when you say connection.
yes. So the best way to handle that is if you want to use the bulbs, you will have to cover up your switch and then use a Hue light switch. They have a wireless light switch that talks to their bulbs. So then you would use that. It's not the most elegant solution, I would say, but it's a solution.
Yeah, that's the benefit of having smart switches. And I say that after 10 years of poo-pooing them and Stacy finally wearing me down and going with Lutron switches. The power's always there. So you don't have to worry about if somebody flips a switch, you still have remote access to it, voice control to it, etc. So that's why we say switches over bulbs would be our recommendation. I know that Hue does make smart fixtures as well.
Yes.
So you could do that.
Well, sort of. So if you go with the Hue fixtures, one, they're very expensive, but you can get some cool things like funky designs or color lights, which are fun. But all of the downlights or other fixtures, they have to be connected to the light switch for power. And when you turn that light switch off, you turn off the access to the Hue again.
You run into the same problem.
So my recommendation for you is to, I love Hue. I have Hue in my house, but I would use your Hue in a slightly different way. I tend to have my main lights be on switches, the Lutron switches.
And you use regular bulbs for those.
And I use regular bulbs. My lamps have Hues. And in my closets and bathrooms, I use Hue plus the Hue motion sensor. So there, nobody's really turning on the lights because the motion sensor, just when you walk in, it turns on. So that's an option.
And to be honest, after much experimentation over the years, I've basically emulated, Stacy, what you have. For lamps, I'm fine using a Hue bulb. I have several. For lights that are like in my kitchen or in my family room where I have built-in lighting fixtures, I use smart switches for those. So that way I always have control. They always have power and I can always adjust them any way I'd like to.
And I will also say to you, the Hue Lutron combination can be made more powerful with the Lutron Aurora switches. These switches actually, you basically install this over your light switch and it locks it's only a toggle switch though, the one that sticks out. If you put that on, what it is, it's really just like a little dimmer thing and it locks the switch into the on position. And then you can turn it on and off using the little dimmer or the little knob controller. And that actually feels like a normal light switch, but actually leaves the power to Hue bulbs on.
Exactly. It always maintains the power. So you don't have the problem of a traditional light switch where somebody flips it off. They can't really flip it off at that point. It's locked into a power on position. And then you can adjust the lighting with the knob and so on and so forth.
Oh, and they actually now have a wall plate bracket that is for the larger slap switches. I don't know what to call those.
Yes. I call them rocker switches.
Rockers, that's it. That is what
Okay.
they're called. That exists, but again, it's a little bit of a bolt-on solution. So I hope, Tommy, this helps you and you have a great experience building out your new house and outfitting it with smart stuff. Remember, if you would like us to tell you our thoughts on these things, give us a call at 512-623-7424, and you will be entered to win this month's prize of a smart hose monitoring system or watering system. All right, now stay tuned for our guest. This week's guest is Evan Kaplan, the CEO of Influx Data, and he's going to tell us all about using time series data and what architectures are emerging in the industrial IoT space. But before we get to him, please stay tuned for our message from our sponsor. This week's sponsor is Nordic Semiconductor. Hey everyone, we are taking a quick break from the Internet of Things podcast for a message from our sponsor. And this week's sponsor is Nordic Semiconductor. And I have Martin Lesund, who is on the cellular side of Nordic Semiconductor's IoT business. Hello, Martin. Can you start us off by telling us, what does Nordic Semiconductor do?
Hi, Stacy. So Nordic Semiconductor, we are a fabless semiconductor company with production and distribution partners. We are specialized in low-power wireless connectivity and embedded processing. Especially for short range, we are a market leader with Bluetooth Low Energy and multi-protocol solutions. And we have been an early mover into cellular IoT with low-power LTM and NB-IoT technologies. Right now, we are also expanding into Wi-Fi connectivity and also looking into DECT NR Plus technology.
All right. And what differentiates Nordic Semiconductor's NRF 9160 cellular solution from other devices on the market?
So basically, it's three things. We have a tight integration. That means we have an application processor, ARM Cortex M33, with its dedicated flash and RAM for the user's application, and a very own modem with the LTM, NB-IoT, and GPS support, all in this system in package, which also includes our power management IC and also our RF front end. The second thing is ultra low power. We have designed our own chipset from the ground up to be ultra low power, and we are one of the most efficient devices on the market. And we continually improve with firmware updates on the modem firmware side and also on the application side. The last but not least is the ease of use. We want to offer a developer-friendly environment for our customers so they can get a fast time to market. So we provide an open source NRF Connect software development kit for free to be used for commercial.
All right. How can any developers get started with testing out the NRF 9160 system in a package?
So we strongly recommend everyone who wants to develop cellular IoT applications to check out our white paper first. It's the best practices guide for cellular IoT development, which is hosted on our info center. We are also having a webinar around this topic around the 29th of June, so check that out. Basically, it goes through almost everything you need to know during, after, and before your development of a cellular IoT product. It goes through the radio technologies, the hardware design application protocols, and everything you need to consider, which has a huge effect on your power consumption and performance of the device. And when you have read up on that, you can, for example, order a development kit or a prototyping platform from one of our distributors.
Okay. And if there's one thing you want people to look into, what is it?
If you're interested or already involved with cellular IoT development, I highly recommend you to sign up for our upcoming webinar, the Best Practices Guide for Cellular IoT Development webinar, which is located on nordicsemi.com/webinars.
Hey everyone, welcome back to the Internet of Things podcast. This is your host, Stacey Higginbotham, and today's guest is Evan Kaplan, who is the CEO of Influx Data. Hello, Evan. How are you today?
I'm great, Stacey. Thanks for making the time.
Man, I am excited. Y'all know that I am a great big giant nerd, and I am probably one of the few people who get excited about time series data. But in this podcast, we're going to learn all about it, why it's important to IoT, and how we should think about architecture for IoT. So let's kick it off, Evan. Before we talk about Influx data, let's first talk about time series data and why we need our own time series database. So
in order to answer the question is why time series data, or why we think about it as its own space or category, let's start with the founder's point of view, which is Paul Dix, who founded the company. And so Paul had built not IoT, but he had been building databases for trading stocks and securities on Wall Street for some time. And every time he would build that kind of database that was functionally a time series database, but meant for trading, he'd have to build a bunch of application code. He'd have to build a bunch of logic. He'd have to build a bunch of stuff around the database to make it work performant with this kind of high flow, high streaming data. And so after a while, he decided, like, this is crazy. Every time I do this, I'm writing this on a Cassandra or an HBase or MySQL, and I'm rewriting the code. And then a bunch of people have to maintain that code over the years. Somebody should actually build a purpose-built time series. And I like to think of Paul as the father of the modern time series. But the reason why time series is a different category is you think about what a time series database, if it's performant, needs to do versus a normal database. And so time series database has to do 4 things, and it has to do them super well that a normal database doesn't have to do at this level. One is it has to be able to write super high volume at super high speed. So you can imagine 100 million to billions of data points a second coming from a large sensor network, right? And that ability to write and make that data available as soon as it's written is critical. And so that sheer ingest capability is critical. 2 is you have to be able to query at pace, because you're not just building systems that monitor these sensors in the IoT framework. You're building systems that have control actions. They spin out a message to a human being. They spin up a new server. They make a machine request. And so in order for these systems to be performant in real time, they have to be able to query that data in real time and have visibility. We're talking about milliseconds. We're not talking about seconds or minutes. So a time series database has to work in that. The third, which is inobvious to a lot of folks who don't look at this space, is most time series data has to be transformed. And what I mean by that is you don't need high resolution data around for a long period of time. We have applications like NIST that are collecting nanosecond data. You do not keep nanosecond data around very long. What you're doing is you're downsampling and summarizing at a regular basis so that you're catching the drift of the events that happened, but you're not keeping every single data point, because that gets expensive and it hurts performance. And the last thing is, if you're doing that transformation, you're evicting data at a super fast pace. So you're getting rid of data quickly. No other databases are built to evict data quickly. And so when you start getting up to these high value, performant, near real-time systems, you need to have a database that has those 4 intrinsic capabilities. And generally, it has to be built from the bottom up with its own storage engine, its own ingestion, its own query engine to really make all that perform. I think that was Paul's insight years ago, and that's what defines the category today.
Okay, now that we know what a time series database is, I think it's important to clarify for people what Influx data does and the fact that you work with both sensor networks and financial networks. So why don't you kind of give us the quick rundown?
So the way we think about, and this is true of InfluxDB, but it's also true of the time series category. There are 2 broad areas. There's the physical world, in which you're instrumenting the physical world, doing high fidelity instrumentation. And that always involves sensors of some kind. And so if you look at our world, we have big customers like Tado and Nest in the consumer IoT. We have Schneider Electric and PTC in industrial IoT. We have Tesla and SunPower and Lucid in the clean energy and electric car market, right? Those are things that have physical things attached to them, some sort of device or hardware at the end of it. And then on the software side, the virtual side, is we have custom telemetry in a variety of areas. We have large customers in crypto, like Solana and Revenue, and in fintech broadly, like Robinhood and Intuit, in gaming and entertainment, in APIs like in MuleSoft and CloudBees and people like that. So it's a really broad set of use cases. The important thing to understand is that the physical use cases, the ones that have sensors attached, behave pretty similarly to the software use cases. The difference is there's a sensor at the edge as opposed to instrumenting the software. But the behavior is really similar. And the volume of data in the physical world can exceed the volume of data in the virtual world, because the sensors can really spit out high velocity data.
Although a lot of times they may not, simply from battery life purposes. I always find that so fascinating, is the number of ways you can play with these things and the number of things you're trying to optimize for when you're setting up a physical network. It's not just like, oh, I really want all this data all the time. You're like, no, I've got to deal with like constrained memory. I've got to deal with battery life. I've got to deal with wireless connectivity, legal ramifications for physical objects. It's crazy.
The places where time series really, really gets interesting are where there are 2 requirements. You're building an increasingly intelligent, either self-correcting, self-healing, or autonomous system in which the instrumentation is critical. So you run a loop in which you collect the data from the time series platform, you watch its behavior, you correct for it, you re-instrument, you recorrect, you re-instrument, you recorrect, and you do that 4 billion times and you get a self-driving car. You do that 400,000 times, you got an increasingly performant automobile manufacturer line. You do that. I don't want to do that in my home, right? I want it to just work, and I want to know that there's a pulse at the end of it. Places where there's increasingly intelligent system and there's a requirement for real time, which, by the way, is a big trend across every industry, right? Who doesn't want more intelligent systems that behave in more real time? Every system designer wants that.
Walk me through what you're seeing your customers want to do with this data and use it.
So a common architecture is, particularly in IoT, is you're streaming data in through a protocol like OPC-UA or MQTT. And that can be done through a dedicated broker, or we've built a native MQTT broker in our cloud in which you're starting to stream the data in through that. You can stream it or you can micro batch it, but it's typically got some sort of protocol associated with it. If it doesn't have a specific protocol, you're generally using a collector like Telegraph, which is one of our open source projects, but Microsoft uses it, Amazon uses it, Datadog uses it. A lot of people use it because it's highly flexible and easy to deploy. It's an agent that will pull data off of whatever system you're looking at if it's not OPC-UA or MQTT or there's no specific broker for it. And so you can use something like that to pour the data in. And then the data is generally stored within the time series database because it's downsampled and summarized. And maybe you put the high resolution data into a data lake and you store it there long term if you want to keep it. Or you store the recorded memory into an object store or a data lake so that you can query it over a long term in a batch kind of orientation. But you'll leave it in the time series storage engine if you want to work with that data in real time. And so you can also use things like Kafka to stream in the data. We use that for our own cloud service. We use a fair amount of Kafka implementations. And so there's a bunch of ways to approach it. And then if you want to act on the data, within our system, we have tools that allow you to issue commands to other services or create tasks around the data. That could be to alert a human being. It could be to issue a machine control. It could be spinning up a new Kubernetes storage pod. It could be a wide variety of things. But the control system actually ends up being pretty important. So does that give you a sense of the data is either streaming or micro batching in? There are a bunch of ways it can do that. It's either getting stored locally if you want to work with it in real time, or potentially it's getting shuttled off into a data lake or a data warehouse or the like.
And how are your customers? And obviously you have a lot, you went through a bunch. Let's talk about maybe your more sophisticated customers. How are they thinking about using their data? Because we went through this era of like data is the new oil, and now we're in like this data is the new crude, and you got to do stuff with it, and maybe we've got too much data. So how are people thinking about using their data and keeping and doing things with their data now?
I think there are lots of ways to think about it, but probably the two most important ways are the real-time control and indication loops. And so if you're running a factory floor, you're running something in real time, you want the data to act on, you want it to signal, you want to be able to feed another system very quickly. That is one way. The other way is if you think about time series data, it is basically foundational for AI. It's pretty foundational, right? Because what do you want to know, particularly for things like predictive maintenance? You want to know what happened, what's going to happen. And so if you take the time series data and you put it into a sophisticated AI engine, maybe a Databricks, for instance, and some of their AI stuff, or some of the dedicated companies that are really good at AI, that's the foundational source data that they want to work with. And they don't necessarily need to work with that in real time. They build the algorithms that eventually trigger it in real time, but they need it to have it. It's the source data. So those are two areas. Is it the source data or is it the real-time control and indication data? Those are the two broad places.
So with machine learning, there is this idea of taking all this data from machine learning, sending it to the cloud, training it there. But there's an emerging effort to actually do a lot more of that processing at the edge. maybe it's just a model that was built with the training data and you're doing the inference at the edge, but that means you may not need all that time series data. So I'm just trying to understand how moving machine learning further and further out from the collection to maybe the sensor edge impacts the type of data that needs to be collected and maybe the types of products y'all will offer.
Yeah, it does. That's a great question, actually, because in a sense, it's a synthesis of what the previous two categories we sort of outlined there is. When you think about it at the edge, it's not that you don't need that data. You just need to operate it on it even quicker because you do not want a network round trip to the cloud. That is a very common IoT architecture. And so the more you can process at the edge, the better off you're going to be. And so it's the same data. And so potentially you plug an algorithm at the edge that actually works on the data, or you still store it and learn, come back to it and place it at the edge. And so it's the same dynamics. It's just, you're just getting closer and closer to where the data is generated. And our point of view, which is why we have the product line that we have, is our primary competitors are Amazon's TimeStream and Azure's TSX. And, our view is that a lot of IoT is 2 and 3 tier architecture in which you have to have something at the edge and potentially even something on the sensor itself. So let's call that the far edge. And so when you think about that, having an API that works across all three, having a model that actually communicates between all three, can summarize the data between all three, that becomes state of the art. Now, we're pretty far along in that, but I wouldn't call us state of the art. Give us 2 or 3 years to continue to evolve each of these pieces. But anybody who wants to compete in this world has to have, I think, all three pieces. Something that can run at the sensor edge, something that can run at let's call it the location edge, and something that can run meaningfully in the cloud, and a relationship between the three. That's our point of view.
Yes. And I will say that, we see that with Amazon and Microsoft building out their base IoT products. So like IoT Core and IoT Hub. So we see that happening with their serverless platforms but not with their time series platforms right now.
You don't see it with the time series. And, and listen, we and others have this tremendous advantage because of this gigantic open source community. There's been way north of 10 million downloads of Influx. And there are 600,000 sites that run it daily. And so you're just talking about just a community of users that already exist out there that are familiar with the API and who are builders. And back to your discussion about IT and OT, in the industrial world, they tend to call it IT, but in our world, we tend to call them developers. They're where the rubber hits the road nowadays because you don't buy these things off the shelf. You don't buy the sensors off the shelf. You don't buy you build the system.
Yes. And before we go, I should have you expand upon that just a little bit, because that's what I fundamentally believe. We could talk about OT, we could talk about IT, but what we're really looking at is a shift in how architectures are built and developed. And in that shift, developers are the kingmakers. They're the people who are doing the work and putting these together. So how do you attract them to your tools? How do you sell your products to those people initially?
That's a great question. And core to both Paul's insight when he started the company is, we use the concept internal called time to awesome, is how long from a developer to pull our tool out to build something useful, right? And we sort of measure that. And we've tried to change that dramatically in the cloud by building a cloud native serverless where they just point the data source and they begin working with the data in real time and exploring it and building their applications. But in general, Influx is known for developers. It's schemaless and it allows them to really interact very quickly. That's been our drawing card. The fact that we scale phenomenally well has been secondary to the fact that the developer can start, which is why we have a lot of home hobbyists who just build on Influx. We have people who manage their pool, their thermostats. We hear these incredible stories of people managing their kid diabetes meter, their blood glucose meter, and, just these totally gratifying things that have nothing to do with industrial or renewables or solar or anything that we really specialize in. That's got to do with having a wide berth to pull in the developers.
Awesome. All right. Well, Evan, thanks so much for coming on the show this week.
Stacy, thanks for having me. It was really fun.
And that concludes this week's episode of the Internet of Things podcast. Please join us next Thursday and don't forget to subscribe. And if you can't get enough IoT news, I would love for you to sign up at www.stacyoniot.com for our weekly IoT newsletter, where we explain all kinds of things that we don't even get to on the show. Once again, thank you for listening and please subscribe.